Hey you guys, we're going to do section 10.3 and it's all about chords. Everything that we do in this one, pretty much everything, is going to be a part equals part kind of equation. Okay? On this first one, we're going to talk about if two chords are equal, then the arcs that correspond with the chords are equal. Let me show you what I mean. So like if I have a circle, okay, I draw a chord. This is the arc that corresponds with this chord. Now, if these two chords are not equal, look at, there's no way their arcs are equal, right? But if I have two chords that are the same length, let's say these are both like 12 long, then the arcs that correspond with the chords are going to be equal measures as well. So that's all we're going to do on this. And it has to be within the same circle or between two circles that are congruent. So that's true for all the stuff we're doing today. In the same circle or between congruent circles. Okay? This is what's true. When chords are congruent, arcs are congruent. Okay? Two minor arcs are congruent if, and I'll explain this, and only if the two arcs corresponding chords are congruent. Okay? Now, what this says is, I'm going to write it again. If chords congruent, then their arcs are congruent, right? Because it's an if and only if, it goes both directions. I'm going to switch. This is a biconditional statement. If I switch the condition and the conclusion, right, switch these, I could go both directions. If arcs congruent, then chords congruent. That's all I'm saying. If chords are congruent, arcs are congruent. If the arcs are congruent, then the chords are congruent. That's what if and only if means. So I could say if, let's say the chords, right here, these two chords are congruent. If chord BA is congruent to chord CD, these two segments are congruent, then, so I'm saying here, the chords, right, the chords are congruent. Then the arcs are congruent. So now I'm saying the arcs are congruent. So I use the arc symbol from B to A. That arc is congruent to the arc from C to D. It also means that if I start here and I switch these two, right? Switch them. If arc BA is congruent to arc CD, then the chords are equal. That's your if and only if, goes both directions. Okay. This one here, I'm going to show you more than you need to know. So just like erase it. I'm going to grab a pencil real quick. Oh, crud. Okay. That's okay. I'm not grabbing a pencil. Yeah, I am. I got it. Okay, sorry. Okay. I want you to see this picture. Okay. I'm going to draw this so that it's not a perpendicular here. I want you to see why we're doing perpendicular. Okay? I've got a circle. Here's my center, and here's a chord. If I draw a segment to this chord, I'm drawing a radius to the chord. Okay, how about through it? It's pretty easy to see. If I do it and it's not perpendicular, this intersection is not perpendicular, then this segment here is not equal to this segment. This is real short. This is real long. Okay? If I draw a circle again, okay? If I draw it so that it's perpendicular, okay? Perpendicular. This chord is perpendicular to my radius. It's also perpendicular to my diameter, right? Same thing. Because of that, I would have two congruent right triangles, a shared side, and then the radii are congruent. If you guys go back to first semester, you could prove triangles are congruent by side, angle, side, angle, side, angle, 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 side, 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 side. And if you have a right triangle, you could use hypotenuse leg. Okay? This is a right triangle. The hypotenuse are congruent. Legs are congruent. So by hypotenuse leg, this triangle on right triangle on top is congruent to the right triangle on bottom. So because that's true, that means that this segment is congruent to this segment. It also means these two central angles are congruent, which means these two arcs are congruent. Okay? So I gave you the background, which I'm never going to make you replicate, but just to understand why. It's a pretty easy proof. So the perpendicular chord bisector theorem, which I never care if you see all the words, whenever you have a diameter or a radius perpendicular to a chord, this radius is going to bisect the chord. Bisect means to divide into two equal parts. It's also going to bisect the arc. So this arc is equal to this arc. Okay? So let's write that. Let me grab black. If a diameter or a radius, right? If a diameter is perpendicular to a chord, then it bisects the chord and its arc. Okay? I'm going to put bisect here in case you forget. It means to divide into two congruent parts. Okay? So in this picture, let's write, I have this diameter perpendicular to the chord. I have to have that part. If EG, segment EG, the diameter, is perpendicular, that symbol means perpendicular, to the chord FD. If that's true, then I've got two things that are true. From E to H is the same length as H to D. And arc, oh, that's E. Because that should be an F, right? F to H, H to D, sorry. Okay, and then arc FG is congruent to arc GD. Okay, this is another biconditional, so it's an if and only if. So the converse is also true. So the converse would say if segment FH is congruent to segment HD and arc, the measure of arc FG equals the measure of arc GD, then you would know that the diameter is perpendicular to the chord. Okay, last one. If I tell you that, okay, if I give you a circle, okay, and here's my center, and I tell you that this segment AB is 10 from the center. Oops. Segment AB is 10 from the center. Then I'm going to tell you segment CD is only 2 from the center. Do you think these are congruent? Does it look like the two chords are congruent? Nope. But if I draw another one that's only 2 from the center, now it's believable to me that these two chords are equal. And that's what this is all about. If two chords are an equal distance, distance is always by perpendicular. If they're two chords that are equal distant from the center, then the two chords are equal in length. And that's what we got. Okay, again, this is the same circle or between circles. Or between congruent circles. I don't know if I said all that. Okay. Okay. Two chords are congruent. Okay. And I'm going to write if and only if because it's a biconditional. The chords are equidistant from the center. Okay. So in this picture, if I told you, I'm giving you, you've got right angles, and I tell you the length from E to G is equal to the length from E to F. I'm saying the distances are equal when there's no symbol, right? If that's true, then segment AB is congruent to segment CD. Okay? So let's talk about when you do these problems, you're using only 3 theorems. You got 3 different situations to look at. Okay? Number 1, I've got 2 chords that are marked equal length. So if 2 chords are equal length, right here, if the chords are equal length, then the arcs are equal length. So this is number 1, right? If these 2 chords are equal length, then their corresponding arcs are equal. On this one, I'm telling you that the 2 arcs are equal. So what do I know about the chords? Well, if the arcs are equal, then the chords are equal. This one here. So this is number 1, right? This is number 1. Okay, on this one. Okay, number 3. It says find the length from H to K. And there's a 7 here. Okay, and then I've got find the measure of the whole arc H to K. So I'm going, okay, is it 1, 2, or 3? Right? I look at the pictures and go, it's got to be number 2. This one says, if a diameter is perpendicular to a chord, then the diameter bisects the chord and the arc. So here's my diameter. It is perpendicular to the chord, and it says that the diameter bisects the arc. So this arc equals this arc, and I'm also bisecting the chord. So if this is 7, this is 7. If this is 70 plus x, this is 70 plus x. They're both the same. Well, I'm going to say this is 70 plus x, and this one's 11x. And then I solve it and do the rest of the problem. You guys, these are all pretty much like that. The only one that's not on the front side, I'm going to flip it over. Here, number 14 is kind of fun. I tell you that the 2 chords are equal length, right? Oh yeah, this isn't it. So that means the corresponding arcs are equal length. So you can see how long the arcs are. And it says find the length of the arc from P to Q. So you got to find this one over here. Oh my. Okay. Looks like This one here. This is number 3. Number 18 says the length from G to E is equal to the length from E to F. This chord is 3x plus 7 long. This chord is 7x minus 21 long. So since they're both the same distance from the center, the chords are equal length. So you could just say 3x plus 7 equals 7x minus 21. Okay, that's it, you guys. Hope you do well. And let me know if you have questions. Thank you.